Hello everyone, this is Rushida. Welcome to my channel. My today's video is going to be on k-mean clustering. First, I will give you an overview of how a k-mean clustering algorithm works. And then we will walk through a k-mean clustering model in Python scikit-learn library. And finally, we will learn how to find the right k for k-mean clustering algorithm. K-mean clustering is the most basic and popular unsupervised learning model. So what is k-mean clustering? So look at this dataset. We have simple data plotted on a two-dimensional plane. If you train this data using k-mean clustering algorithm, it will look like this. It will put this group of data in one cluster, this group as another cluster, and this group of data to another cluster. You can see the red, yellow, and blue cluster if you use 3 as k. It takes unlabeled data and labels them. So you can use k-mean clustering algorithm on unlabeled data to prepare them for supervised learning model. It has other uses as well. We'll talk about it later. With human eyes, we can easily look at this data and cluster them, right? Intuitively, you can see that this group should be one cluster, this group should be one cluster, right? But a machine do not have human eyes, right? There should be rules for machine to figure out the similarities or closeness of the data. Let's take a little closer look how machines will figure out clusters. Let's assume that in this data set, we pick that these 3 random dots colored in red are 3 centroids. We just picked randomly using a random function. The task of the k-mean clustering algorithm will be setting these 3 centroids in the right place. It starts by assigning each of these dots to one of these centroids. So how we assign all these dots to one of the centroids? So let's pick one dot. Now we will assign this dot to one of these centroids. It simply takes the distance. The distance from each of these dots, you can take the Euclidean distance, then the shortest distance wins. As you can see, this distance is the shortest, so this data gets assigned to this centroid. In the same way, we can assign each of these dots to one of the centroids. And it can look like this. So all this data can be assigned to this centroid, and this centroid probably will get all of this data, right? And for this one probably will get only these 2. Now, as all the data already got assigned to its centroids, then we'll take the average of all the points of each group and find our new centroid. So we'll take an average of all these data and find a new centroid, where the centroid probably will be the center of somewhere in this circle. And the centroid of this group will probably be somewhere in this area. And centroid of this little circle will be inside of this circle, right? The new centroid assignment can look like this, right? When we have the new centroids, we will follow exact same procedure we did here. We will calculate the distance of each of these points to new centroids, assign the dots to the centroids again, and then take the average of each group to find another centroids. So this will keep going on until your centroids do not move anymore. Here you can see in this picture, I actually developed the algorithm, ran it, and this is how the centroid kept moving. First, these were 3 random points. Slowly, with each iteration, those 3 black centroids kept moving to the cluster center, and it got settled there. Now let's dive into the code and see how we can develop a k-mean clustering algorithm using Python scikit-learn library. Here I have the Jupyter notebook where I developed a k-mean clustering algorithm for you. So we used this orangequality.csv dataset, and where we have all different kinds of parameters: size, weight, bricks, pH, softness, harvest time, ripeness, color, variety, blemishes, and the quality 1 to 5. Now we are checking for null values. There is no null values. For this algorithm, I'm going to use the size and weight. I'm only taking 2 variables, but you can take more than two variables. And here with a box plot, I wanted to check if there is any outliers. Your K-mean clustering algorithm can be very sensitive to outliers. And we are seeing a distribution as well. You can see even in the distribution, we don't see any outliers. If we look at the scatter plot of size and weight, this is how the scatter plot looks like. I simply use df size and weight, the two variables, and dot values to get the values of these two variables in an array. This x values is going to be our input data for the training. The tricky part and the most important part of the k-mean clustering is to find the right k. So how many cluster you want? In real world, most of the time you don't see the data that are so clearly and nicely divided into three different flocks. A lot of time the data are so scattered. So in those cases, it is hard to understand actually how many clusters you want to make. Okay, let's see if we can come up with the right k. So I'm taking a range from 1 to 19. You can take a range from 1 to 5, 1 to 10, 1 to 11. That's your decision. I decided to take a wide range. So I'm taking 1 to 19. And you see in k-means function, I'm using this n clusters I. So number of clusters is going to take a k value of 1 to 18. And in it, so the k means plus plus. It means initially how it will pick the centroids. There are two different ways. Let's look at the documentation. Okay, there are two options, the random and k-means. In the beginning, in the overview, I said we can do the random. So that is one way. And another way is k-means plus plus. So I'm using the k-means plus plus this time. So why? In k-means plus plus, it selects the initial cluster centroids using sampling based on an empirical probability distribution of the points, contribution to the overall inertia. So this technique speeds up the convergence. Okay, so instead of taking the random, I decided to take k-means. Please feel free to try with the random as well. And the random state 32. And simply then fit the x values, our input data, to the k-means function. Remember that in supervised learning models, we always had to feed input features and labels. But this is unsupervised learning model, so we have only input features and no label. And inert.append k-means.inertia. So what is this inertia? Let's look at the documentation. So here is the inertia, sum of square distances of samples to their closest cluster center. This is kind of the evaluation techniques, and we want the inertia to be as small as possible. And the training, these are the inertia we have got. To find the right k, typically we plot the inertia. So we have total of 18 inertia because we tried 1 to 18 different k's. This is called the elbow method. When you see the bend, this is the right point. So we see that actually in 2, when is the number of cluster is 2, the first bend happened. And the second bend happened when the number of cluster is 3. And eventually the rest of the curve was quite smooth. First bend, 2, should be our right k. And we're going to try with 2 and 3 both. Let's see. So this time, as we already figured out the number of clusters, so in k-means, you put the properties number of clusters 2, and we are using k-means plus plus to find the initial centroids. Feed the x values, and then you can find the cluster centers. And then you can use the fit predict function to get the label 0 or 1. Label means actually we do not have label in unsupervised learning model, but we have two clusters. So if the cluster is 0 or 1, you can see which data belongs to which cluster center, which centroid. Here we are plotting the data divided by the colors based on the cluster 0 and cluster 1. And I'm also plotting two cluster centers or two centroids. So you can see these are our final centroids, and this is how the data get divided into two clusters. And now, as we have seen, and the second bit is coming at 3. If I have to use this data set and do an unsupervised learning model, I definitely would use 2 clusters, but for the fun of it, let's use the 3 clusters and also see how 3 clusters divide the data. So this time I'm passing n clusters 3. This time we will have 3 cluster center because we have 3 clusters. If we predict the data, we will get 0, 1, and 2, 3 labels. Now if we plot the data based on 3 labels, 0, 1, and 2, and color them red, green, and orange. Also, I'm plotting 3 centroids. So this is how it divided the data into 3 clusters. Now you decide if you want 2 clusters or 3 clusters. But based on elbow method, you should take the number where the first bend happens. Here the first bend happened where the number of cluster is 2. I will definitely take the number of cluster as 2. But still, we tried with number of cluster 3 as well, just to show you how it looks like. That's all about K-means clustering algorithm. Please check the description box below where you will find the link to this notebook and also the dataset so you can try it for yourself. I hope this video was useful for you. Please like, comment, share, and subscribe if you like this video.